Yes. Okay, so as mentioned, I'm responsible for building and maintaining the analytics platform at Turbine. We've got a number of different things here that we're doing, and we support teams across the Warner Brothers portfolio. So our mission here is to provide a fast, secure, and robust analytics solution that allows studios to generate insights flexibly and easily. We do a variety of things. We collect data. We store it in the cloud. We use Amazon Web Services for that. We do a lot of work to transform that data and do interesting things with it for our analysts. Our analysts are responsible for analyzing the data, and then we have a number of things here for recommendations as well. So. I like this slide a lot because this slide talks quite a bit about how, sorry, I'm having a little bit of trouble speaking here for a second. Give me 1 second. I'm not able to hear myself. Is there a...
Do you want to just try this mic?
Yeah, maybe.
Yeah, just try this. I can show you other microphones. I think they can, yeah, that's live. Go ahead.
Does that work better? All right, I'm going to try this instead. Sorry, folks. So I like this slide a lot from Gartner because it really talks about the way that the analytics space is evolving. So as you can see, we've got descriptive, diagnostic, predictive, and prescriptive analytics. One of the things that we're really interested at Warner Brothers is to be able to help the company kind of move up the value chain. What's interesting about the work that we're doing is that analytics is sort of kind of in its infancy across Warner Brothers in some ways. We've been focusing a lot on kind of the descriptive diagnostic things, but the neat use cases are all kind of around getting ourselves to where we can do sort of some of the more interesting use cases. And so my team is responsible largely for kind of helping the rest of the company actually be able to do that. So when we talk about game data, one of the things that I like to just highlight briefly is that there are a variety of different kinds of data that we're responsible for here. The games produce a lot of telemetry data, so we basically go and provide player activity data. That tends to be things like kills, moves, mission checkpoints, side missions, location, acquisitions, and so on. One of the things that you'll find for some of these really big titles, and we're talking about titles like Mortal Kombat, Injustice, Shadow of Mordor, for example. These are all pretty large AAA titles that are on console, and some of them are starting to move to mobile as well. There's a tremendous amount of customization that happens for this data, but there's a lot of similarities between the different genres as well. So for example, if you're a fighter game like Injustice and you're producing another game which is in a similar genre like Mortal Kombat, a lot of that sort of telemetry data is the same, and it's very, very dense. So we're able to go ahead and actually play back individual matches between players because we actually have instrumented every single move in the match. So it gives a lot of opportunity to be able to do interesting things with that data. On the game console side, because the games get released, and shipped and pressed to a disk and so on, we basically try to instrument everything, and there's not a lot of updates that you can do with that data. Once the game is in the field. For mobile games, it's a little bit different. The event model is going to evolve over time because you can do frequent updates. You can do basically a patch of the game at any point. We also collect additional data around profiles, so summary data and state information about a player. There's also transaction data that we bring in, and we basically join all this together to be able to give our analysts, who are our internal customers who are within Warner Brothers, an opportunity to do what they need to do. The neat thing and the challenge, of course, is that telemetry data is huge. So we're talking about potentially billions and billions of events. Even just Mortal Kombat, which just launched a couple of weeks ago, we've already consumed around 20 billion events from players there that we have to store and manage. So what kind of things do people want to actually do with this data, right? So, we developed the platform in my team. We support analysts across all the different game teams within Warner Brothers. There's a lot of the sort of typical things that people are looking for, obviously. Things like how many kills were there, what were the most successful heroes in a particular game, what sort of side missions tend to be the most popular, and what are the most popular weapons, and so on. A lot of, as you remember the earlier slide, things that have to do more with basically trying to do descriptive analytics, diagnostic analytics, trying to be able to understand sort of what happened in the past and sort of, why it happened. So if I kind of go back to this slide a little bit, which maybe I could have spent a little more time on, trying to kind of use telemetry data to understand what people were doing in the past was and is still, a core part of what we do. But it starts to get interesting when we start to think about, can we use that data to predict what's going to happen next, right? So moving from kind of hindsight to foresight, and then ultimately, how do we, if we can predict the future a little bit, how do we actually influence that future and influence players? All right. So if you look at the blue ones here, these are starting to strive a little bit more towards those sort of predictive and prescriptive use cases. So how can we improve playability? So we do the same thing as a lot of companies now in the space are doing, which is we look at the historical data and we try to figure out from the information that we know there, what it is that players have been doing, so we can actually make the game better. How can we increase engagement, right? We can increase engagement by trying to help players to have a better experience from the information that we collect there. Which players are going to churn? We were talking a little bit before about churn prediction. And which players will like the next game, using that information to help us build better games. So one of the most important parts of the work that we do is looking during game development for how do we actually improve the game. So we do a lot of early instrumentation of the game that our QA guys use, our open betas are used for that. We're constantly improving the game based upon that information. So here's a little bit of a graphic. This is up on the web. There's a link there from Polygon. But this talks a little bit about Shadow of Mordor in particular and how some of that data is used to be able to get some insight into what players are actually doing. So this is kind of fun. So which weapon was basically the one that seemed to be most popular? I guess not surprisingly, it looks like people really like swords. There's also a bow, which is pretty useful for being able to hit Uruks from far away. For those of you who don't know, Shadow of Mordor is basically a game in which you're kind of out in the world. Your family's been killed. You are taking revenge on the Uruks, which are really, really powerful orcs. This is all part of the kind of Lord of the Rings franchise. And you have the ability to assume a wraith shape or a human shape. So if you're a wraith, you kind of go invisible. You've got some special powers. You can do things like influence the orcs and control them. If you're an actual ranger here, you have to kind of deal with things in a little bit of a more traditional way, where you're shooting them and sneaking up on them and so on and so forth. So it's a lot of it is sort of taking revenge on the orcs. As you can see from this graphic, which is a little bit old, this is back in February. About 72 million total players were killed by Uruks. So it's a tough game, and if you play it, you'll find that you get killed pretty quickly, and you get killed frequently until you can sort of increase your skill there. So that's about 1 death per hour, I guess, overall. But for each death, there's basically vengeance that happens. So players will avenge themselves, and they'll go and look for the Uruk that killed them. So of course, you come back to life. You can go and go after the captain or whatever that was slaying you. And as you can see, that players avenge themselves about 10.7 million times so far. A couple more stats. So about 5.5 billion Uruks killed overall. So that's almost an entire planet's worth of Uruks. Shame on us. 1.3 billion Uruks dispatched by other Uruks. So one of the things that is neat about the game is that you can influence the way that these different enemies kind of work together. So they're in bands, and you can actually kind of influence the power struggle between the different players there, or between the AI, I guess you could say. And actually, over time, you'll see that the orcs will battle each other, and there'll be different ones that get killed, and other ones that ascend to dominance, and so on. So that's pretty interesting. And then there's a reference to the 200 million orcs who are dominated. So, you know, you can actually, as I was mentioning, dominate them and subjugate them as well. So the game has a very interesting AI system, which is, there's been a lot of press, a lot of write-up about it, called the Nemesis system. You can look it up online. The Nemesis system is really a way of being able to dynamically create adversaries. So there are algorithms that will generate actual nemesis, or actual orcs with special powers who know who you are and who are trying to get you. And the cool thing about that is, as you can see, the system's already generated 9.5 million unique nemesis, which means that these are characters that are potentially, you know, unique to your experience. So everybody has a different experience, and the characters are generated through, you know, a variety of different artwork and sounds and characteristics and so on and so forth. So each of them has, you know, their own names, their own fears and hopes and dreams, as it says here. You know, basically about 6.6 million vendettas have been resolved against, you know, these ones that came after you. All right, so let's get a little bit into the actual data pipeline. So the rest of my talk is going to be mostly about kind of what worked for Shadow of Mordor and what we're doing to actually build a more advanced data pipeline. So this is kind of going back to my original picture. So as you can see, like many data pipelines, we collect data, we store it, we transform it, we give it to analysts through various tools so that they can analyze and reason from it and make recommendations to the business. We use just a basic ingestion tier for collecting the data, so the console games will actually send the data through a REST service to the back end there. We use Amazon S3 as our cloud storage, you know, 11 nines of durability. It's hard to beat, and it's cheap, so it's a good place to kind of store your raw data and do some processing on it. We use MapReduce, typical Hadoop. We're using it over Amazon Web Services, so we're using the EMR version to do our transformations, data normalization, you know, some deduping, and basically massaging the data into a format that we can then use to load it into the data warehouse. We do a lot of work also with Python to get the data into a tabular format, and the tables then get loaded off into Vertica. And Vertica is really where most of the analysts are accessing it. So they're doing ad hoc queries there and so on and so forth, and then ultimately visualizing it in Tableau. So, you know, we've got kind of a daily export that happens. We do a batch job, which runs once a day. We can go ahead and load it, and we do daily reports. So it works at scale. Hadoop is obviously very, very good at being able to scale to these kinds of you know, amounts of data that we've been talking about, but it's slow. You know, it takes about a day to kind of be able to surface information that analysts care about, and when you're in the middle of a launch, that can be a critical period of time. People usually want to know within minutes rather than hours. So the traditional kind of patterns of dealing with you know, BI data really don't scale particularly well for this kind of a game. It works. We did a good job with Shadow of Mordor, but we also had to, you know, build up some pretty big systems, and they're expensive. You know, one of the things that happens is data warehouse costs get really excessive. So you're putting all this data into Vertica. Vertica is expensive. You know, you're paying for the underlying storage, you're paying for, you know, the VMs that Vertica is running on top of, and then of course you're also paying Vertica for the privilege of actually using that data. So it can get, you know, sort of astronomical in terms of cost. Data modeling and queries, they become pretty unwieldy as well. So again, you're dealing with vast amounts of data, you're dealing with all of the data in the warehouse rather than an aggregate. Processing time, as I mentioned, even using Hadoop can be very slow, and you also, as you deal with this kind of scale, are going to have to deal with corruption. So occasionally files are corrupt, your gzip doesn't unzip properly for your files, network issues can introduce problems, or, you know, drop packets making you know, some of your files corrupt, and so on and so forth. So a lot of challenges to dealing with this much data. There's a lot of potential solutions that can be employed there. We've done a lot of work to tune up the existing system. We did some work, recently to tune the existing architecture. So one of the things that you can do when you're dealing with shoving billions of events into S3 and then ultimately loading them into Vertica to kind of speed up your load time and your processing time there is simply decrease the amount of data, right? So there's a lot of ways of doing that. There are ways of doing that sort of actually at the console level where you're able to go ahead and do some data sampling there. Typically we don't load absolutely all of the events anyway because we don't need it. I mean, basically we're not tracking individual users, right? So these are all used for, modeling at kind of a high level. But, as you start to get your data sampling and you start kind of turning up that knob and sampling more and more, you do lose some fidelity in the data. So that's something to consider. Evicting unused tables is another thing to do. As I mentioned with the console games, we tend to find that the game teams instrument everything and worry later about what they're going to actually do. So, as it turns out, once you're in production and you start talking to what analysts are doing, you find out that, wow, there's a lot of tables and things that were created, that were loaded into Vertica that actually maybe they're not using right now, right? So again, this kind of old BI model where you throw everything into your data warehouse and then you go ahead and query it, starts to break down at some of these scales where you've got analysts who are really focused on kind of very, very specific use cases. So we were able to do a couple of things there in terms of decreasing utilization in Vertica by basically getting rid of tables that aren't currently used. Now, remember, we store everything in S3. So the data will come in, it's going to be in S3 in its raw format. We'll create a tabular format. Most of the data comes in JSON, so we store that. We make the tables, basically. We store a copy of the tables in S3, and then we load them to Vertica. So in the future, when an analyst comes to me and says, oh, by the way, those tables I told you to delete it, shucks, I actually really do need those, we say, okay, we've got the raw data, we'll go ahead and reprocess it for you. Okay. There's also work to optimize the in-database post-processing and modeling. So, once the data gets into a data warehouse like Vertica, chances are you're going to be doing additional post-processing. They're creating some dimensional tables, you might be creating some indexes on top of it, and so on. And so, we do work with the customers to try to optimize some of that work. One of the challenges that we have, and I've heard this from a lot of people in the industry as well, is that data can change at any point. It's going to change less once the title is in production, but certainly as you're getting towards production, the schemas are changing all the time. In this system, we actually get the data in an unstructured format, and we infer the schemas. So when a schema changes, we say, oh, okay, there's a new column here, and that column, might require us to do some additional, changes. So we basically merge old versions of the schema together. So it's a lot of work that gets done in the database. The other thing that we can do, and we've started to do for some of our analysts, is we simply load some of the highest priority tables that are for their most important executive reports up front, so they get them, quickly. The other solution, which I'm going to talk about briefly, is building a new architecture. So instead of this sort of batch model we've been using, stream the events instead and actually try to transform them in real time. Move all your processing and your modeling upstream so that your data warehouse is really just holding data that it needs and you're not actually doing very much transformation work there. Getting into sort of more of a data model where you load data into your data warehouse as analysts need them, you evict the data when you don't need it, and doing it in a very dynamic sort of way is another option there. And then providing a variety of flexible query options. So basically you can do your processing and your querying from the analyst side at different parts of that data pipeline. You don't have to wait until it's all lying in your data warehouse. And then basically trying to leverage data recovery mechanisms kind of out of the box. So the new platform is quite a bit different. We've done a lot of work now for this new game coming up called Batman Arkham Underworld. So it's our first mobile game that we're supporting. It's going to be coming out later this year. You should check it out. Basically what we're doing there is we provide a BI plugin for the mobile devices so that they can very easily integrate with the overall stack. It allows them to send the data to an endpoint, and instrumentation of a game takes about a sprint, so about 2 weeks or so to really get the whole thing done, so it's really pretty fast. The data goes into our ingestion service, which is a big Kafka queue. So we get all these events just flying in, and we queue up a week's worth of that data at a time, and we consume it. Let's see, I got a pointer over here. Yep. There we go. So, and then we're using Spark now instead of Hadoop. So basically, Spark is a technology that is sort of, some people think, the successor to Hadoop. It's much faster. It does a lot in memory. It avoids a lot of the sort of network overhead of Hadoop. We're taking Spark, and we're actually using Spark streaming. So we're going to take the data coming in from Kafka. We're going to actually process it through the Spark consumers right over here, land it into S3. We're also giving, as I mentioned, customers a lot more control over the data upstream. So if you look over here, we've got customer services framework. So they're able to go in there and actually do a bunch of programming if they want to using Java or Python or Scala. They can go ahead and transform the data themselves. They don't have to write a ticket anymore and say, oh, we need this ETL job for you to do. So we're actually pushing more of the work to the analysts there and supporting them, of course. There's also the opportunity there for doing queries against the data directly using Spark SQL. And Spark natively provides machine learning algorithms, libraries there that they can use, as well as there's a version of R that now works with Spark. And in fact, in Spark 1.4, which is the next release coming out in a couple of months, it'll be there natively. So really great to be using open source technologies. We have much less vendor lock-in as a result, and we're able to manage the infrastructure here, internally as well. And then finally, on the bottom there, we've got the BI services. So rather than putting the data into Vertica, we're putting it into Redshift. Redshift gives us the opportunity to do things in a much more dynamic way. So loading data in, scaling the size of the cluster on demand, up or down, able to manage costs a lot better, and then still using Tableau for the actual dashboards and so on. So this really provides us a very integrated environment. Rather than having our analysts and our customers having to go out and patch together a lot of different tools, we provide a complete in-house service which allows them to look at data from the ingestion tier, do the processing via exploration and modeling tools, and we're going to continue to build those out for the analysts, and then publishing them to a variety of tools that can be used for either reporting or for, in the case of Librato, live monitoring of the stream. So it's kind of the best of both worlds. You can support real-time use cases where you want to see data instantaneously, and we're actually loading the data to Redshift every few seconds at this point. Or if you want to do a huge batch job over a lot of historical data, you can do that as well. So it's kind of the Lambda architecture, right? You can go either way with either sort of real-time cases, or you can go into the typical batch cases. As I mentioned, because we have a client plugin, integrations with the games are quick and simple, and don't have to move data around anymore between different systems, and don't need much in the way of external connectors and drivers. So very, very useful for our customers. Final lessons from Johnny Cage. So event scale at launch is really unpredictable. You need to be really elastic. The best predictions I've ever seen for how much data we're going to get at launch have always been wrong. So for Shadow of Mordor, we were 6x what was predicted. It's a good thing that the game was so successful, but it's also a good thing that we built a system that was tested at 10x. Right? So always anticipate that things are going to do really well, and always have a plan to scale things up if need be. You can't predict all your questions in advance, so analysts are always going to come to you after launch and go, oh, by the way, I want to find out X, Y, and Z. So the more that you can give them flexible options to be able to actually do that, the better. In particular, giving them the ability to fish, as I say, teach them how to fish rather than doing all the fishing for them is really a much more effective way to work. And of course, people are always going to want things faster and faster, so always strive to get your platform something as close to real time as you can, so that you can handle these use cases, especially at launch, because at launch people they want to know within hours, how's the game doing, how many people downloaded it. Waiting 24 hours is a long time. So, all right. So I should mention a quick plug that we are hiring. So if any of this stuff is interesting to you and you love the Boston area, you can find me on LinkedIn, Steve Stalzer. Just shoot me a note. Always looking for people with talent and experience. So, quick question? Oh, great, thanks.
What's the expected life of all the data you use for Mordor?
Yep.
And now that Mordor has sort of been like months out since launch, what type of stuff are you doing with that data today?
So the expected life, the expected life of the game is pretty long. So the game is expected to continue to be pretty actively, played for the next couple of years, as of course, some successor is planned. The data, we retain all the data. So since we have it in S3 and it's in storage, relatively cheaply, there's a lot of sort of modeling that's done against that data. It's mostly, as you would expect, talking about, or looking at the data from the perspective of improving player models that we can use for the future. So, a lot of what you learn from a game at launch, you really can't apply anymore in the console world to that game. Now, in mobile, it's different. You can always do a quick update of the game and add new features and so on. It is used to some degree for actual console updates. There's always downloadable content. There's always kind of new releases of the game. Shadow of Mordor being a game of the year, there's a big game of the year release coming out pretty soon that's going to kind of roll a whole bunch of DLC and stuff into it at once. So, there are some changes that you can make there. But a lot of it is really planning for the next game.
Hi, two quick questions. Do you find that you're able to, as a publisher, cross-collateralize the insight you're developing around one title for other IPs that may even be in different genres? Yeah. And if I can remember the second question, do you find that you're able to bring the optimizations about what kinds of instrumentation are actually consistently being used by developers back to developers so that you're not getting overwhelmed with, as you say, the gazillion empty tables that you have to then filter? In other words, can you use your understanding of what of everything this instrument is actually being utilized across the different titles that you have that to basically tell the teams which things to focus on instrumenting so you're not slammed with too much at the end? Okay.
Right. So in terms of the second question, the key thing is really working with them on the data taxonomy, right? So figuring out what are the questions that they actually do want to have answered, figuring out how to actually instrument that in the game. We don't work too directly with the game teams in terms of that because we're not analysts. So we do have, the analysts tend to be working on what the data taxonomies are and kind of thinking about that. And my job is really to just make it possible for them to do whatever they want. But it's a good point that we don't want to be bringing in and paying for a lot of data that we're actually not going to use. So I think having a little bit more data governance around how we do things is really key. That's something that we're starting to work on as well. First question was about the sort of cross title or cross studio analytics. We're seeing more and more of those kinds of use cases. It's a lot easier within the same genre, right? If you're looking across genres, it's an RPG versus a fighting game. In terms of the profile data, maybe there's some parallels there that can be applied, but in terms of the event data, it's often hard to kind of draw inferences between them.
Okay, all right. Thank you, Steve.